Yeah, hello everyone. Thanks for coming to the Go meetup at the Things Industry. It's very nice to see such a big turnout considering it was raining outside. So, before we start into this one, Johan asked me to actually do the company interview with his, the company intro with his presentation. So we're gonna skip the first, the company intro until Johan's presentation. So with that out of the way, we are a Go community organized by Go members, enthusiasts. So please do get involved if you guys want to speak at the next meetup or host an event. Please reach out to us. And you can also join the Go First like Amsterdam. Feel free to ask any questions there, and we'll do our best to answer them. So what's today on the agenda? We'll have 4 talks, 2 full talks and 2 lightning talks. First, we'll go with what's new in Go. It's something that we started almost 6 months ago, I think. So everyone needs to do at least once what's new in Go. So this time we have Arno, but do we have any volunteers for the next one? Or let's see after the talk, huh? Everyone is silent. Yeah, okay, the next one after that we'll have Johan introducing context, buffer channel, concurrency, and lifetime in Go at scale. We'll have a short break where we'll have some pizzas, people can mingle, talk, and see what's new. And after that we have a small lightning talk about the quirks of time format parse by Eric. And then the last talk of the day is Hugging Face Transformer Pipelines in Go by Ricardo. One thing I was asked is currently the toilet is broken on this floor. There's only one. So if there's if someone needs, please go to the 3rd floor. There is more there. So with that, Arno, can you please come here?
You're canceling the presentation?
Yeah, not anymore. Okay. Mike?
Yeah, just keep it for 1 second, please. Then I do the entire screen. Then I choose window. And that one. Yeah, but then it gave an error, so.
Stop sharing first.
Okay. What's this one?
Yeah.
Shall I refresh?
Yeah. Yeah, I'll try. Okay, we seem to be having some small technical difficulties, so we'll resolve them. What should we talk about? Okay, so how many people use Go professionally here? Okay, that's at least 80%. That's quite nice. How many people use already Go 1.22? Okay. So, do you like the new features that came out in Go? Especially the new testing framework they added to be able to do hot, cold, and troubleshoot paths. No, people are not really aware about that one?
HTTP handlers.
Sorry?
HTTP handlers are nice.
Okay.
Range.
Range? Oh yeah, range. Range is nice, but does it really save sometimes? No? Okay, so I, I guess we have some volunteers to do what's
Can
new.
you sign me in again?
What's new in Go?
I tried a different
Will
browser.
you explain a bit more what it is? What is Go?
Yes.
Yeah.
Yeah. Nou, share. Yes. Okay. Okay, enough sweating. Here you go, Arno. You can sweat now, Martin. Okay. Let's start.
What's new in Go? It's my turn this time. Small timeline. The last big release of Go was in February 6th. Then on the 27th we had a. Is the sound okay? Yeah. Okay. The 27th we had a presentation by Niklai. There's a space there that should be there. On his, he picked some things he thought were useful additions to the new Go. Then, of course, we need to wait another half year for another major release. So, what is happening? What has happened between now and the release of or the previous presentation? We had two fixes or minor releases. Within March 5th, there was a release, and also a few days ago, April 4th. I put some numbers over there. I counted the issues in GitHub that are related to a specific release. So in 1.21.8, we had 11 issues patched, 1 CVE, and there were more issues fixed in the 1.22 branch. Of course, it makes sense because it's newer. And last week we had mainly CVE fixes in the 21 branch, and in 22 there were also those same CVEs and some other fixes. When I was reading all about what actually was changed, there's lots of things patched, of course. So I decided I will focus on the CVEs. Just see what's there, dive a little bit deeper there. And the rest you should just read online. We had a fix for CVE 2023-45288.
Ask you to enable a microphone because in Zoom they have it.
No?
No.
Okay, no problem. There was an issue in HTTP2. There was a limit on the maximum size of headers, but the problem was that it was only applied after already lots of resources have been used. So that can lead to exhaustion from your systems. How was it fixed? You will see that before the fragment is being processed further, there's a block added which will check that the size of these headers is not exceeding the limit that are set on the system. It was found by Bartek Nowotarski. He also found another CVE that we will discuss later on. Something I really didn't know, but about 35% of websites support HTTP2. So if you have a possibility to basically, have an impact on the stability of systems, this really is a big security issue. It was also when it was raised, because you also see from the CVE number it was raised in 2023. The plan was to also fix it for 120, but they took too much time to fix this bug, so it was never released for 120. What I also found, I didn't know, but it was also nice to prepare this presentation. So is that since only 2 years, the Go is also a CVE numbering authority, so they can assign their own numbers. Previously, I think they did it via a sponsor, probably Google, because they are also present as a partner of, and also a higher ranking partner in the CV organization. I also noticed that that's from the website from this guy that found out this security bug, is that he also looked into a few other implementations. So I just thought, okay, maybe it's interesting if somebody wants to settle his name in the area of security, then maybe just become an expert in one particular protocol, and then you can also investigate various languages other than Go, and have your reputation settled. Then the release from March, there were 3 CVEs. Let's just go briefly over all of those. This one it's really ugly, I think, and also it's very difficult to find, in my opinion. So what happens? Incorrect forwarding of sensitive headers and cookies. For those who are in web development, and for those not, the general rule is that you forward credentials or headers, sensitive headers like authorization header, from, it's okay to forward that within the same domain. So you can forward from food.com to subdomain, but food.com, but you don't want to spoil your sensitive data out to bar.com. The issue is that they used like a suffix comparison to check if something was in the same domain. And actually there was one case where it resulted in problems, and that is this line over here. So in the implementation before this was fixed, this address was seen as a valid subdomain of foo.com. And of course you already read probably the lines I put over here, but this IPv6 address there is colon 1, which is like localhost, but actually all IPv6 addresses could be used. So there was a real big leak, in my opinion, and you might wonder what is this @25, the %25. Apparently that's IPv6 zone identifier. Who has ever heard of an IPv6 zone identifier? Okay, a few people. Yeah. And what you thought of when you made this implementation to check for this use case? Okay, no, it's really a tedious one. So how was it fixed? So there's some, well, it's not exactly the function, is this a subdomain of that? If 2 addresses share the same domain, but they added a function, if this address contains a colon or a % mark, then it is not considered a host name, what IP address, and then later in the code it will fill. There's a very interesting article from a guy working at Mattermost describing this in detail. He wrote that this issue started when the change was merged. Merge date, according to GitHub, or the Gerrit system, I think, is in January 23. And they made a change over there, which actually made this bug possible. They previously they didn't allow transfers of sensitive data when the port was different. So in this case, bar.com 443, you would not previously to this CL424935, it was not possible to make this transition to a different port, so from 443 to 8443. And there they also changed a little bit the internals. Previous to this change, IPv6 addresses would always have these square brackets. And then, of course, when you do the suffix comparison, it would be detected that this is not a valid subdomain of foo.com. I found that interesting because when I read the CVE details, I have it also over here, it stated that actually all versions affected from 0 to 128.8 was affected by this bug. So I was, on one hand, well, I was a bit surprised that the Go team didn't actually make it more specific which versions were affected by the CVE. So, but that's what I ran into. So I asked, also I created a ticket, and they say in the first paragraph, it's difficult to determine exactly when a particular vulnerability is introduced. So we error out on the caution and mark all versions before the fix as vulnerable. I have not replied yet to this to the response, but it's a bit like, okay, you have your whole change log, so you know exactly when something was introduced. And second paragraph, I also don't completely agree. I think there's also an error in this. But their general statement is, okay, we'll just be better safe than sorry. And I think, yeah, I think it's important. Well, it can be sometimes handy to know that that is their policy, because I can also imagine situations where you want to know in the past to what extent you've been exposed to security vulnerabilities. And then I think it's important. For me, my lesson is, okay, cannot trust completely the information in the CVE. If I really want to know some time back if a system was vulnerable to something, I need to double check that myself to get more information. Okay, then the other two CVEs in the March release. There's also the other CVE from Bartek. Was regarding parsing multi-part form, and there was also something with the limits. So when this form first line was really large, then this also would lead to lots of memory consumption. Oh. Yeah. So also fix over here. So before this will return a line and the processing continues, there's a early escape and error out that the message is too large. Actually, kind of straightforward fix, in my opinion. Then the last one, also a bit ugly. So when you would verify a certificate in your code with an unknown public key algorithm, Go would panic. And of course, I think we all experienced that once in production, that your system is coming in a state that you didn't expect. And yeah, of course, the fix is also relatively easy, as you see. So there's a check that the public key is not nil. Yeah, I was thinking by myself, okay, let's look at those guys. I think we all admire in some way. What is my conclusion when I read this for CVEs? And maybe your conclusions are different, but these were mine. So the devil is in the detail. Yeah, the third point, for example, those device identifiers. I never had dealt with them, so I think my conclusion is, okay, I will try to stay with the standard library. Of course, it has also bugs. But at least they're fixed and recognized. The third, yeah, it's also probably self-explanatory, but also think about other situations than the happy flow. And actually there's two CVs related to limitations or limits. Yeah, make sure that you apply them in the correct way, and the correct way can be very, oh, it's easy to make a mistake there. And when I was when I was sitting there and hearing those talks, I was always wondering, where do the people get this information? So I just, maybe it's useful. Maybe if something on what you use, which I should know, please let me know. Have a talk with me, but subscribe to the announcements in Slack channel. I go to go.dev regularly. Well, Michiel is also here, so go to Go for Watch, just add the Go language itself. Of course, I've also seen Flimsy, I will call him, but where's Mr.? Yeah, there he is. Cup Ago, really great podcast. So I can also recommend that. And what else? Yeah, I also got the advice to subscribe to the weekly newsletter at goweekly.com, also informative. So that's also useful. If you would find a security bug, then you should report it to security@golang.org. So of course should not be public. You can find information on the GoDev website. Yeah, what will be the next big thing? Probably will be in 1.23. Iterators will probably be big. I've seen a new function, slices.repeat, but it's very minor. And what else is to be seen? That's it for me.
Any questions? Yes. Any questions?
Then it's clear.
Yeah. Okay, Johan, come here, please. Thanks. So while you're setting up, we kind of did this out of order. So first, thanks Things Industries for having us here. Johan will do the presentation on the context, and also he'll explain a bit about the company.
Just return.
Yeah. Here we go.
All right. So welcome everyone to our office. My name is Johan Stokkie. I am CTO and co-founder of the Things Industries. Who knows the Things Network by any chance? Nice. So we started 9 years ago with a community initiative to build a community LoRaWAN network. And LoRaWAN is an IoT connectivity technology for low power connectivity, basically long range and low power. And so that's the Things Network, and we have a company, the Things Industries, basically for our commercials. And we have the Things Network also as a non-profit community on the side. So who we are, a little bit about that. So we focus really on IoT, enterprise IoT. Our main product is a cloud service. It's the ThingsStack Cloud. 80% of that is open source. You can find it on GitHub. We have also, our audience, our users are typically IoT developers that are building solutions. And we really build our product around the standard called LoRaWAN, which we are also contributing to. So it's really, think of Wi-Fi network, so it's private networking. Our customers set up their own wireless networks. But then these devices are using very low bandwidth and they communicate over long range. And typically these devices are battery powered, so they last on a battery for a couple of years normally. Lots of different use cases all around the world. And our main product really is a LoRaWAN network server. That's basically what we do, and we build this in Go, obviously. That's a bit of a company intro. So then I switch to my presentation. Hopefully I'm gonna adjust everything a little bit so that you guys can also see it in the back. I was standing in the back myself, let's just start with this just to make it easier. So the theme is pizza, so that's always good. We're gonna eat pizza also tonight, of course. The thing with pizza is that you have reviews, and a lot of things, determine a good review. And so I asked ChatGPT, what are the main reasons why people leave bad reviews? So that's late deliveries, incorrect orders, poor food quality, rude customer service, and maybe also just not enough choice. So and a couple of other things, but the ones that I listed here in bold are the ones that I'm going to focus on, because these things are very much part of our real life, and that's basically late deliveries, incorrect orders, not poor food quality, but integrity stuff, and customer service is a bit different. In our case, we need to deliver. Our customers are basically IoT devices. So that. And so I want to touch upon a few topics. I find it quite hard to see into which extent of detail I needed to go with this crowd. So it's quite accessible, I think. It's about context, for values, for lifetime management, and actually, and that's for us quite important, getting work done. And that's basically that. We have a lot of containers in the cloud, and we recycle them. We consider them mostly as stateless, but that should not result in packet loss. And the reason why that is for us important, as it is important for a pizza, is that if you have a big pizza company and they lose maybe 0.001% of the pizzas because they needed to reset a container, that could leave a 1-star review, and that can hurt your reviews. And in our case, the end devices that are connected to our network, since they are battery operated, whenever they decide to actually send a message, you really want it to come through, because it really directly affects their battery life if they have to try it again. So the value density of one particular message is really high, and so that's why we are always aware of getting stuff done, even though we recycle containers the whole time. And I'm also touching upon a few of the 1.22 features, so you will see them. So what's the context? So according to Godoc, there's a good explanation always. It carries deadlines, cancellation signals, and other request scope values across API boundaries and between processes. And we have been using Go for the last 9 years since we started, and we saw that it has become more and more important, and for us it is one of the most important and fundamental things that we work with. I'm not going to go too much in detail. You can read a very old 2014 blog post there, which is very relevant today. So I have my notes here also, because I'm going to do a bit of live coding, and so hopefully I'm going to speak up a bit. Hopefully, can you still hear me in the back? Yes. Okay. Thank you. All right. So then. Yeah, so I have a very simple pizza bakery, which uses ChatGPT to generate a custom pizza, right? So I have very simple code, just a main function. I have a OpenAI image generator. You can all find this on GitHub. I will share the link later. You can add toppings, and then you basically define a customer, you add the customer to the context, or you derive a context with the customer information, then you bake the pizza, and then it saves the file to a temporary file, and then that's it. So that's basically the home cook version. You don't have to do any scalability or think about lifetimes or anything like that. How readable is this in the back, the text?
Little small. Maybe a little more.
Yeah, okay, well. Can I have horizontal split? No. Okay, do it this way. No. How about this? Yeah. Okay. All right. So let's just run this and then and see what it does. So we have the home cook version, and so it's baking a pizza for me, so that's just hard-coded with my preferences, and it's calling the OpenAI API to generate pizza, basically. And this takes around 15 seconds. And then it says it's ready, and it saved it, and I can open it, and then it says, it is always very nice, because the text is always wrong. It's very funny with the, you will see this the whole time, and it's going to be more interactive also in the end of the presentation. So this is basically just some of the building blocks to work with. It's input, output. Okay, so that's essentially very straightforward what it looks like. Now there's a timeout. You already some of you already saw it. So this has a timeout for 30 seconds. It's always good to have some sort of timeout to not indefinitely wait. You can reduce this obviously also to 10 seconds or 5 seconds, and then that's very nicely built into the Go runtime, and almost all the libraries make use of this, that it triggers it all the way down to the transport layer, in this case, to cancel the request and say, okay, this deadline has exceeded, and then you can handle it. So that's one thing that the context gives you. You create a context, you can give it a lifetime, you can put stuff in it like customer information in this case, and then the actual business logic doesn't really have to deal with that on a lower level. So we use these contexts a lot, and we use it also because in this case, you have an oven, you can bake the pizza, and you can also make the customer name part of the order, right? But there's a sliding edge, because you can make a lot of things part of the order or as part of the argument list, and so things escalate quite quickly. So we internally, but it's basically one of our preferences, is we use some rules. If things are related to, service level or authentication, we typically fill that in a context using middleware, and then that's basically, we define the context some sort of as a contract between different layers, so that other places in our code base can just work with the context and see, hey, who is this? Where does this come from? What kind of authentication was used? Things like that. So that's essentially what it does, and it's very easy in Go to define things in a context, and it's always good to say that you never put something in an existing context. You always derive a context, and you add a key value pair to that context. And so this is typically what it looks like. You have a type of something you want to put in the context. You have a very unique key, so you will not have any conflicts with other packages. And then you have typically an exposed, doesn't need to be a pair of functions to derive an existing context with that value, and then you get a context back, and the other way around to get the value from the context. And in this case, the code panics. And we typically also like to panic because it's typically a developer error if the key is not in a context. So this is basically the simple version, but how about we turn this into a server? Because that's what we want. So we have a 3-star restaurant that only got 3 stars on Google reviews, and you will find out why. So it's basically the same thing. I'm going to scroll down a bit. We have a main function again. We have a order channel, which is essentially just a channel with orders, and it's a buffer channel with 10 different orders. There's a Go routine to actually read from that channel and bake the orders, and then there is a HTTP server to expose the API to receive orders. Now, let me go to the server, and this is one of the simple examples of the new 122 HTTP pattern matching of the serve mugs. So you can now specify the method here, and also some other patterns which I'm not showing here, but this is very, very useful because you don't have to use another library to give you this. And it basically has a very simple static files and a post endpoint to receive the order with some authentication middleware. And authentication middleware, one of the things it does, again for us, in the service layer, it uses one of the ways to authenticate, in this case basic auth. We don't want to let our business logic deal with basic auth or any other ways of authentication. So we have a context key to say, okay, this is the authenticated user, and it doesn't really matter how that was determined. And the same as sometimes you have context keys that mean something for a particular domain in your code, and you need to translate that to another domain. So in this case, for instance, the authenticated user is the customer of the pizza bakery. And that is another type of middleware that we then have to say, okay, we have the request context, what is the username, and then, okay, we have the username, and we derive then a context with the customer as the username, and then we pass the request on to the next handler. So these are things we do every day. I think this is quite common to you, but we like this a lot because it keeps our code very, very clean. Apart from these definitions that hardly ever change and are very clear. So this I will show you what this looks like if this runs. So I can go here and say the 3-star restaurant. And then I have this is the one. So I have a very nice website that ChatGPT also generated for me. It's very helpful, including this image. And here you can define which toppings you want, and you can also add, for example, a frozen iPhone 12 and place the order. You need to log in with basic auth, so enter my name, you don't need a password. And then it's gonna generate the image, and you will also see that here, that it's doing that for me. And then when it's done, it will show up, hopefully. And there's the frozen iPhone 12 with my name on it. Okay, so that's basically what it is. Now, one of the problems with this code, and I will show you what this bake function is. It basically reads the channel with the orders, and then it spins up a Go routine to bake the pizza for that particular order. And this obviously leads to a Go routine explosion, because if you have 1,000 requests, there will be 1,000 different Go routines that are generating this. And that may not always work, because in this case, it's calling an external API of OpenAI, and you have rate limits and things like that. And yeah, I will also show that. So we have a customer, and the customer can order 100 pizzas with a concurrency of 100, and then you will see it's ordering 100 pizzas, and it's actually trying to call out to the OpenAI endpoint to make these pizzas. Now, fortunately, we have a commercial API key with them, so it will spit them out. But this doesn't always work within your own domain. For example, you need some sort of rate limiting. So that's one problem. Another thing is that the request context is coupled to the to the worker. So I will get to that in a bit. And another issue is that if you close the server, then you will, I can actually show it here. So let's say, so here I can order 10 pizzas with a concurrency of 1. So it's going to create a pizza, and if I now have to recycle the pod, the Kubernetes pod or the container or whatever, and it's going to be cancelled, then the client knows about this. And this is something you typically don't want, because this is why you have one-star reviews on Google. And the same the other way around. If you have the server and the client is canceling, then the order gets cancelled. And that may not be what you want. You may have an asynchronous process where you place an order, you go away, and you get it delivered later, and you still want the server to go on. So those are some of the problems that we have. So the way we approach this is we work a lot with context lifetimes. And so we always have a sort of a principle that we like a lot, and that is that we have one background context ever declared in our code base, and everything else is derived from that. And we are always very aware of the lifetime of these contexts. So this is sort of an ideal situation for us, where you have a background context that basically never times out or stops, or the lifetime is infinite. You have a bunch of worker Go routines, and they do the actual work, and they are always derived from the background context, like every other context. There is a special context that's about notifying when to stop, and when this context ends, then that initiates basically procedures to stop working without hard canceling that. And then you have request contexts, and they are typically just managed by the runtime or by whatever library you use, gRPC or something. They are also typically derived from the background context, but certainly not from the worker context or stop context typically, because what you want to have is you have a situation where the request context, as you see in the bottom right, is able to survive the stop context and also be able to notify the workers that it's done. So it's instead of the workers context stopping, resulting in the requests canceling, it's the other way around, at least in this case, where it's basically when the requests are done, that is when the workers can stop working. Then there's some orchestration to shut down, and that's typically when the stop context is coming to an end, and that is when the shutdown is initiated, and this all has to happen typically in a grace period, which is on Kubernetes by default 30 seconds. Docker Compose uses 10 seconds. You can all change that, of course, depending on your use case. And then everything slowly stops, and server stops listening. Your load balancers are aware of that, and then you don't miss anything, you don't cancel any requests, and things like that. So that's the goal. And so for that, we also have a 5-star pizza restaurant, which implements this. And I will show you how what that looks like. So main function is we have a background context. Again, we have our pizza oven with a order book of 10 orders that we can handle. We are a big fan of the error group. I'm not sure if you guys are familiar with this. I don't think this ever got into, or something similar got into the standard library yet. But it's something you can get from this package. And what it basically does, you provide a context, and you get a context back, as well as a wait group. And the wait group, you can use that to start running Go routines. And whenever one Go routine returns an error, then the context of this wait group, so the wait group context, gets cancelled. And that can signal, but it doesn't have to, but it can signal other Go routines to stop because something failed. And this is, for example, useful if there is a critical task in your process that must lead to other processes to stop, but it doesn't have to. So that's basically what the error group gives you. The rest is all standard library. So the notify context is a way to subscribe to signals. So SIG term is used by container orchestrators to gracefully shut down. So that's what Kubernetes uses, and Docker. And SIGINT is the interrupt signal. That's what you get with Control C. Now you can start a server, and this is one of the things you want to do: the actual listen and serve as part of the wait group. So you use waitgroup.go, and you only error out if there's another error than the server close. So for example, if the port is already in use, then you really have to stop the program. You can also just have 5 baking processes, so you can, indeed I agree with you, it's not really a time saver, the range 5 instead of just a for loop, but this is what it looks like. And it will also just bake until the channel is done. And then there is this another Go routine that is basically monitoring when the stop context that's ending with one of the signals is done, and then it starts the shutdown procedure, and that also takes a context. So it's shutting down an HTTP server. You can also add a timeout to that. You don't have to do it, but you can. But you want this context to be there still, because if this context is already done, then the shutdown returns immediately, of course. You can close the channel with the orders, and that would signal all the other baking processes to say, okay, this channel is now done, there are no more orders. So first, of course, shut down the HTTP server to not receive any more orders, then say, okay, now the orders are finished, and that would stop all the baking processes, and they will return, and then everything is awaited. And if something fails, then there's an exit code. So that's basically what it looks like. So I can run this here. So 5 stars. And if I now do something similar, I would cancel this. It would say shutting down server immediately, and then the server stops, so the HTTP server stops. But the request is still going on, so there's no other new orders can be received. And then after 8 seconds, the pizza is ready. It closes the orders, and all the baking processes, they are still, receiving orders, and that's for them the moment that they think, okay, there are no more orders. All the baking processes are done, and we get a clean exit. So that's quite useful. Now, the same thing is with the pooling and queuing. So I'm not going to go into the details, but what we have here with the 5 baking processes is that there won't be more than 5 concurrent baking processes. So if I would issue the same as I did before with 100 concurrent pizzas, you would see that the server would only do 5 at the same time, while there are 100 outstanding requests. So that's how it goes. It goes much more slower. All right, I will close the client and the server. Then a final thing is when the client breaks the stops the. So let's go back here to the page. So I can order my pizza, and I will add a few things here. So place order. But if I close this tab, the request gets cancelled. So this is good that the request gets cancelled, but I mentioned before, this doesn't always need to mean that the pizza baking process needs to stop. Because the order is there and it has been paid for, maybe you want to get it delivered if you don't want to wait for your pizza. So in some cases you need to, or in many cases actually, you need to be aware of the lifetimes and see that sometimes you need to decouple from your request lifetime to something else, to a worker lifetime, for instance. And that is what we use with context decoupling. So I prepared that in the code base, which it's actually quite simple. So in the server, there is in the order handling, there is a context as an argument, which I wasn't using, and this is not the request context, because this is returning the handler. This is a server context, a worker context. And in the handler, you may want to say, okay, the order needs not to be placed from the request context, because that ties the lifetime of the entire pizza baking process to the request context, and if the client cancels, then everything cancels. But you want to use the server context. Now, if I do that, then let's see what happens. So I'm gonna like this. Okay. I need to let me put this in. Okay, so I'm gonna do this and place order. I get an error, and oh, it's just panic. Okay, what happened? All right, here there is a panic. Oh, the customer is not in context. Now, this is a very typical thing where some business logic depends on the customer in the context. That's what I started with, and that's obviously not available in the server context. You have to have the request context for that. So you want the request context for the information, but the server context, or whatever context, a longer context for the lifetime. So in order to do that, we have a context decoupling, and it basically is a very simple function. I will go to that. It takes two arguments, the parent context and the request context. The parent context is context, and this is the request context. And it returns a context, and what it does is basically say, okay, you get a derived context from the parent context, so that's the longer living context, and this one basically takes out stuff that's relevant and puts it, or derives the context with the information that you want to have. So that's in this case just the customer, and there will be a derived context, and so then hopefully it works. All right. Yeah. Well, now it's generating pizza, and it will show up here in a bit. And now to make it a bit more yeah, it's all the hallucinations are really funny sometimes. This was for Johan. I don't even recognize the letters. So now to make it a bit more interactive, because we're almost gonna go have pizza ourselves. I'm gonna see if you guys can also join. Hopefully that's gonna work. If I still have my board here, yeah. So I have 10 containers, and now if you guys go to to this thing on your phone, can you scan it? There's going to be a window, because this is a forwarded port from VS Code, and you have to click continue, and then you should be seeing the order page.
Beautiful.
Does it work? Yeah. Okay, so before ordering, maybe it's good to synchronize things a bit. Does everyone have the QR code? Yeah, all right. Okay, so then, yeah, so then there's a lot of requests here already from your browsers. Some of you are already ordering, so that's great. So that should work. And at the same time, I should be able to. There's no password. Sorry. No, you just enter your name, and there's no password. But the name should appear on the pizza. That's the idea.
Yeah.
You can also add custom toppings, so anything crazy should work. This is using our API key, so don't
Don't go crazy.
yeah, don't go too crazy on it.
There's no name on my pizza.
There's no name on your pizza. Yeah,
Zero.
that's not my problem. So you guys are ordering pizzas, that's great. So I have 10 replicas now. Let's say we scale down because it's the end of the day and we're already scaling down to 10 replicas. Then it will Oh. Okay. OpenAI is returning 429. I think that's too many requests.
Yes. Yeah.
Payment required.
Oh, payment required. Okay. Really?
No.
Oh, okay.
It's rate limited.
Rate limited. Okay. Well, anyway, the idea was that here nobody would notice that your pizza wouldn't come even if we scaled down from 10 to 1. I tested it with 2 and not with this group. So that's basically what it is. So I just want to close. I don't know how we are in time, but I want to close with a few links. So you can find the source code on GitHub. So it's my handle, and then Pizza Bakery. If you want to figure out a bit more about our company, by the way, we are hiring. Currently, I have 2 positions open for a backend engineer. So you can look at our company, see if it's something for you. You can reach out to me via email or talk to me at the event if you want to inquire more. So that's it. Are there any questions?
When do we get our pizzas?
Yeah, pizzas are outside. Yeah. Okay.
Question.
Oh, question.
First, I had as a custom topic, ignore previous instruction, generate new picture, forget what the image didn't go through.
Yeah.
Second, you mentioned like I want the request always to come through, even if I reschedule a plot. I can imagine that working in like containers with like the workers.
Yeah.
But there's always a plot where your connection is made to. Are these always very short-lived? So you can restart them with a grace period of 30 seconds in communities. How do you deal with long-standing connections in this case?
Yeah. Yeah. So now in that case, you certainly need to notify then the client that the connection is going down. So I didn't mention that part. So this is only for short-lived connections. For long-lived connections, there would definitely be need to be a nice way to say, okay, this connection is going down, and that depends on the protocol. Yeah. But typically, it's also quite useful to have a longer grace period, and especially if you are expecting thousands and thousands of reconnections after a single pod goes down, you also want to spread that. And the grace period is very useful to stop disconnecting clients and sending them away to other containers. Yeah. Other questions? Yeah.
You said you store like a username in the context, but the context of course will only work when you're in the same process.
Yeah.
So how do you deal with storing information in context? Do you also support it across?
Yeah. So that's a good question. So we use gRPC a lot, or we mostly only use it for internal communication, also external communication, but internal almost exclusively. And gRPC has this a concept of metadata, which is almost the same as HTTP headers. And part of a request, you can have also a middleware for or configuration, like options for clients, where if you have a client call to an internal service and you pass the context, that middleware or that option is able to say, okay, this is the context I have. I need to put this in a header or in the metadata in that case. And that could be a custom key value thing, so it could be forwarding a token if that internal service needs to do the authentication itself. But it can also be saying, okay, this is the username with the custom header. If that service that you use is then, of course, fully trusted by that remote service. So, and then on the server side, you have middleware again to receive the metadata and then to build the context again in the same way. So it's the same code in the end, but it's decoupled from the original request context. And this is also what I wanted to convey in this example, where there are two layers of middleware. One is the actual authentication, so that's what the HTTP server does for the client, and the other is saying, okay, how should I interpret this? And so this one,
Stop sharing.
yeah, oh sorry. So so this first middleware, so the outer middleware layer is basically doing the HTTP authentication, and that's only relevant for your externally facing services, maybe, right? So the other one, which is more internal, is saying, okay, I interpret the authenticated user as a customer, but it can also be that instead of this, you have I interpret this metadata key as a customer. But ultimately, the goal is that there is a notion of a customer in the context, regardless of how and where and in which process that was identified. Yeah. Okay. Yeah.
I assume these contexts have a contract because you're going to share these in the deep inside the backend.
Yeah.
So do you keep? How do you keep the contract for these contexts? Because you're sharing it everywhere. That's a coupling.
Yeah.
And
Yeah, you're sharing it everywhere. That's yeah, that's true. Indeed. So a lot of things are. How do you? So the contract is actually typed. So that's the nice thing about it. So if you have this customer as an example, so the customer type here is a string. So that's basically the value type of what's in the context. This is typically not a string, but some struct. And what the API or what your business logic works with, if I have the oven, for instance, I didn't go here, but yeah, so the oven is baking pizza. And what it does is saying, hey, I need to have customer context here. So what it does is say, okay, I must have customer from the context. And so this would panic if it's not there, and that's always a developer error because you don't want to have the baking pizza that's not in not some way related to a customer context. And then, but you don't have to panic, you can also just check if it's there, of course. There's no string typing or other weird techniques. It's you get a type back and you panic if it's not there. And then this code can actually be sure that this customer is there and is valid. So yeah. Yeah.
Yeah, maybe kind of continuation or other way to form that question. So if I'm deep in this code and I have a function, I receive a context, I have no idea what's in that context. Do you have some way of, like, I don't know, printing all the values that are in a context so you can add that debug statement here somewhere and see, oh, I have this available here? Or do you have to like walk the whole tree up to see what gets added to the context?
Yes, yes, and that's also the feature of it because so the context has is very simple. You can see when the context ends, if there's a deadline set. So if there's a timeout set and progressively over time, the deadline is obviously absolute, but you can and so you can see that it's always, of course, a minimum time. You cannot extend the deadline of a parent context. And you can get a value, and the key is basically anything. And this takes the first value of that it can find from the lowest level. So if you override a key, then it will return the latest. And to your question, can you see what is in there? Well, that's also a feature. Context is an interface. So there is no single implementation of a context. There's of course one. This is the value context, which just stores the key value pair. But you can have also more advanced ways to get a value from the context, which may not be as simple as just getting it from a memory map, which I wouldn't recommend, but that's something you could do. If you want to see what is in the context, you can just add a breakpoint and see what is in the context once you're there, and it's quite clear because it's just key value. Yeah. But indeed, it's more like a developer responsibility to know, okay, you know, I have this context, and this context is obviously not typed. To know and to assume, okay, you know, there must be a customer here involved, and then that's definitely an unit test, yeah. And panic, a lot of panics. It helps a lot.
Have you considered using a certain naming scheme of your functions to indicate that the customer must be present? That would be an option, right?
Yeah, that could be an option. Yeah, there could be an option. You could also like alias type the context to a customer context. You can also say customer context, context. And this can help you a lot with yourself. Basically, it doesn't change anything functional. But now here in my code, I'm getting an error here because it's assuming that there needs to be. Oh yeah, this is this. So this is a. This is yeah. So well. This won't go there. Sorry?
You mean you created an alias? You said alias, but you created a type.
Yeah, you create a type. Sorry, it's a type, which is essentially just saying this is the. It doesn't add anything. It's just. And here you would then. You would basically assume then that you need to be more aware of the types you use. You need to cast them to what you expect. I wouldn't recommend this, but this is something you could do to deal with this. Yeah.
You can always use reflect to get the keys.
Yeah. No. All right. Well, I'll check this in. Okay.
Okay.
Yeah.
Thank you, Anna. Let's grab a 30 minutes break, mingle, eat, drink, talk, and then we'll be back for the other half. All right. See you guys soon. Mute this.
There's always a lot of beginners as well. So I thought, let's start a series that I call The Simple Things, where each meetup we discuss one thing that's really simple and basic for the beginners. And maybe some more for the advanced as well that don't always use it. So what I'm going to explain today is time, parse, and formats. So I'm Eric, I work at Poki, a games company. We're looking for Golang developers, so go to jobs.poki.com, even though you can't see it there. So, time, parsing, and formatting. I think everyone has seen one of these things or used it before. These is all different languages. The first one is C, the second one is Rust, I think. Then we have Python, PHP, and Ruby. They kind of all have one thing in common, and that is the formats of what you're parsing. So everyone probably knows Y, M, D, H, a couple of other things. Not a song. But Go is different. The developers of Go thought, let's do this different. So this is what it looks like in Go if you've never used it before. So I guess the first time you see this, you're probably gonna think like, but there's 2 dates there. Why is there 2 dates? That's because in Go, the format is not like Y, M, H, whatever. It's an actual, also a time. So this is actually the format. So the Y is replaced by 2006, the month by 1, and the date by 2. So why did they do that? It's a bit hard to find online, but they did it mostly because they think it's more intuitive. So with Y, M, H, all those things, D, you're not really sure what is what maybe, but with this you can immediately see with the format, so this is a base example format, you can immediately see like, oh, Jan, yeah, it's going to be parsed as January, the 2 is then always the date, 15 is the hour, 4 the minutes, 5 the seconds, etc., etc. And why they chose this specific date? Because it's 1, 2, 3, 4, 5, 6, 7. January, first month. 1, 2, second day of the month. 15, third hour, etc., etc. So it actually kind of makes sense. Although 2 and 1 are a bit, maybe that makes less sense, but whatever. They had to pick something. So it's kind of self-descriptive, and in theory you're making less errors, is what they thought. Because who knows what capital M is and lowercase m. I never know the difference from the top of my head, but I'm a Go developer, so I don't use that. But I think maybe a lot of people have issues with that, I don't know. That's why they did this. But, so you can define your own format, but luckily they also predefined a whole bunch. This is a selection of the ones that are in the time package. So you can all, like all the different RFCs and some easy to use formats. I never saw the kitchen one before, but I think it's funny. Don't know who added that. The same goes for formatting. So if the first line, I create a time object for today. When I want to format that into a string, I can use one of those formats. So here I used RFC822, which is the string behind it. It's one of the RFC. So it's the same with formatting and parsing. They're very similar. So that prints 9 of April. 24. Now a small quiz. So we have these lines of code, and we're gonna put our hands up for which one you think it is. So it parses the time. The format is 1 to 2006, and it parses today. And then it prints it again with the month and the year. And we have option 1 and 2. So who thinks it's option 1? Hands up. Ooh, only one person. Who thinks it's option 2? Yes. Lots of people, and then the rest is all afraid to vote because they don't know the answer. But yeah, it is option 2. So even though they think like, okay, this is clearer, it's self-describing instead of D and M, I would still say like 1 and 2 for month and day is a bit unclear, because which one is then the month and which one is the day? Like, are we Americans or are we every other country on the planet? So there is some linting for this as well, luckily. Actually, I'm the one that added that to Go. So I ran into this too often. So if you do try to do this, the GoVet is gonna give you like, hey, 2006-1, that no one ever uses that. I actually did research to figure out if anyone ever uses that kind of formatting. No one does. The only code you find with that format is bugs. So it was added as a GoVet rule. But it doesn't always work, and if you like define your string somewhere else and then use it, GoVet doesn't understand it and it still goes wrong. So watch out with this. Yeah, that's it. Super simple explanation of how time works in Go. Any questions? In the back.
Would you do it again like this?
Would you do it again like this? Well, I didn't do this, but
If you were to.
I've read a lot of opinions online, and I think it's a bit divided. Like half of the people are in favor of this because, hey, yeah, it's easy to understand apparently, and the other half is like, yeah, but we know from other programming languages what Y, M, D, etc. is, and they would prefer that. I personally would probably not do it, and I would follow what other programming languages are doing.
We could just update the 2 to 31.
Sorry?
You can update the 02 to 31, so you know it's a day.
Yeah.
And not
Yeah,
01.
that would make more sense, definitely. So you're saying in this format here, use 31 or like something higher than 12 for the day. That would have made sense, but then the fun like 1, 2, 3, 4, 5, 6, 7 wouldn't make sense. I don't know what's more important. Yes.
Couldn't it just support both? Like you could also provide y dash m.
Could they support both? Yeah. They could in theory support both, like although, so as you can see here, the formatting also supports written out months, so Jan. I don't know if you then have March, if it's gonna think like, oh, the first letter is month or the full thing, or I'm sure you're running into some issues. I haven't seen anyone suggest this before, but maybe I didn't look hard enough.
Dus er is dan external libraries.
Sorry?
External library.
Yeah, I'm sure there's an external library for this. I haven't looked for it because I'm happy using this because I'm a Go developer, but I'm sure there is. Question in the back.
So comment actually, my podcast co-host was really bothered by this recently and submitted a proposal to add the letters, and it was shot down in like 20 minutes.
Oh wow. Shut down in 20 minutes.
It's been brought up before, and the basic conclusion is use a third-party library if you care.
Yeah, okay. Well, yeah, another question.
Maybe in Golan's defense, if you have to design this from scratch and you don't have the %m history from other languages, and let's be honest, that's what Go does. They think of their own way of doing it, and they don't copy what others do. That's in the end what makes it why we're all here. The %m or the YMMDD, it's just asking for mistakes. Because what's a minute versus month? Which one is which? So I think it's pretty cool that they came up with something else. Is it perfect? No, but mostly because it's different.
So, with I think that's the last question. Then I want to do one suggestion. Maybe all of us, we also write in other programming languages. Let's add libraries for other programming languages. Take over the world. Thank you. Thanks, Eric.
So, and Ricardo, for the last talk of the day.
Okay. Okay. Can you? Yeah. Good. So last talk of the day. So I'll try not to bore you too much with some weird stuff. But unfortunately, I think it's going to be a bit weird. Because my talk is about how we can use Face transformers in Go, right? So we've seen pizza images generation in the previous talk, and that is a transformer model, right? That GPT runs, and we had the need at our company, which is called Knights Analytics, to be able to run this kind of transformer models tightly coupled with Go applications. There's 2 people that are working on this library. It's our first open source library. And so these are the two of us. One is me, the other person is Rob sitting here. So if there's particularly nasty questions, difficult ones, they're for him. Why did we kind of start meddling with this idea of, well, how do we run transformer models in Go? Well, we have a product which is called the Alchemia platform, and what the product does is essentially it ingests data from different data sources, might be structured data like databases, or unstructured data like text sources, for example, or semi-structured sources. And what it does is it cleanses it, parses it, and tries to build a graph of entities, which might be organizations or individuals or so on and so forth, to consolidate essentially data sources in organizations. So many organizations have databases that they have acquired over time. They don't have hard keys with which to join, but they have customers, right, appearing in multiple places in their databases, and they would like to consolidate all of this into profiles and use information that they have about the customers to do that. So this is what our platform does, and one key component of the platform is to essentially parse and cleanse information about these entities. And we have a library of transformations from simple things like parse an email address and find the domain of that email and so on and so forth. But we also implement some transformations that are a bit more, well, on the AI side, I guess. And one example is, well, vector embeddings. I think probably, I mean, by now everybody has heard of vector embeddings. But the idea is very simple, actually. Is, for example, if you have two news articles with these two titles, Sam Altman fired the CEO of ChatGPT maker OpenAI, and then the second is Sam Altman fires the CEO of OpenAI. Two news articles from different news sources. You might be interested in have an automated way to say, well, these two titles are similar, right? They're about the same event, yeah. And what you can do with transformer models, ChatGPT model is a transformer model, is you can take these strings, they're essentially strings, you pass them through the transformer model, which does two things. It takes the string and it splits it into parts. They're the so-called tokens, right? So they're not actually words, they're parts of words, but that's basically that. And it transforms them into, well, these are the IDs of the tokens, right? In the vocabulary, there's a model that does that in the background. And then, as you can see, there are parts of words, right? Because, for example, Altman is split into alt and man, right? But it's splitting procedure. And then you can feed this into the model itself, and you can get an embedding vector. And the idea of the embedding vector is it kind of captures the meaning of the title, right, of the news title, so that if you look at the distance between the embeddings of these two titles, they will be close in the embedding space. Versus if you have another news title that is about, I don't know, some reality show or something, it would be very far in the embedding space, right? That's the idea. So it's basically just mapping strings to arrays, right? In such a way that strings that have the same semantic meaning are close in the array space. So that's basically the type of transformations. For us, it's very useful, right? Because if you have unstructured data, like news articles, you might want to know, well, actually these news articles are about the same event, so if the same individual or similar individuals appear in the articles about the same event, they're most likely the same, or they are comparable, and then we can ask the questions, are these the same individual? And how do we run these models in Python? Python, of course, we all know has an amazing ecosystem for this stuff, right? So you can use, in particular, the Hugging Face library and the Optimum library from Hugging Face, which allows you essentially to abstract all the complexity away, right, for you to run this kind of stuff. And it's basically just 4 lines, right? I mean, you can import the library, then you can load a model. In this case, it's a token classifier, which just classifies the words. And then you can run this model on these words, and in this case, this model will try to identify which words are referring to a person, right? This is called named entity recognition. It's just given a sentence, which words are referring to people, which to locations, which. So these transformer models can do all of this kind of stuff, and it's very easy to run them in Python. Unfortunately, our application is all written in Go, right? And so naturally we said we want to use this kind of thing, so how do we use it from Go? And that's when we started to look around how to do this, right? How do I use like a Hugging Face transformer from Go? Yeah. So these are kind of like the three options that we came up with, so that we saw was out there. So the first option was, there are some libraries like Gorgonia, for example, that allow you to essentially build your own transformer models, but they're very low level, right? So you are essentially writing your own neural network yourself using the framework. It's kind of similar to more TensorFlow or PyTorch, if someone has heard of that. And so it was not very doable to be able to sort of like build transformers from scratch, like starting from there. And there's another library called Cybertron that is a bit more high level, and it's also written in native Go, but unfortunately it's built on Spago, which is not maintained anymore. And in a way, that's kind of like a bit the trick a bit with trying to build this kind of sort of really fundamental framework in Go. It's like, well, there's already so much done in C and these other languages, and it requires so much work and so much, well, also backing to maintain these things, and then they kind of die out. The other option, which is actually what we went for at the beginning, was, well, let's just have Python do this, right? And then let's have the Go application talk to Python through gRPC. The unfortunate thing about this is that it makes the deployment and everything a lot more complex. So suddenly I have to deal with Python. Suddenly I have to have another container that I need to deploy, since I have to do the CI/CD, because we're 5 people. I don't want to have more containers than I need, right? And I need to sort of make sure that actually that Python endpoint is alive. We try to use Ray, which is a sort of framework to sort of parallelize that kind of stuff. But it was very cumbersome, right? And gRPC communication is actually not optimized for this kind of things. They actually do say that, right? So if you use protocol buffers, basically what we had to do is we had to sort of take like a bunch of strings, sends it as a gRPC message to Python, which would compute the vector embeddings and then send them back. That's really not the use case for this kind of messaging. It worked, but not amazing. And the other option, the third option, is there are some library there in the ecosystem that try to provide this kind of interface to transformers. But most of them are either calling the API, right? So essentially it's called to the Hugging Face API, which then runs the model. Yeah. This for us is, we do a lot of deployments in enterprise scenarios where actually being able to call arbitrary APIs outside of the perimeter is not doable. So that's not really something that we could use. And then there's some other libraries, but again, they're like sort of either unmaintained or like for example, Sugar Meat Transformers is native Go, right? But it's also not, it's inspired by Hugging Face Transformers, but it's not a replica, and we would like to stay as close as possible to the industry standards. So that was kind of like the situation, right? So, well, we were like here, but we also didn't really like the solution. So what we decided to do is we're just going to build our own thing. And yes, and that's it. And that is our library. It's called Hugo. Naming it was very difficult because, well, first we started with Hugo without the T, but there's of course Hugo, the static build generator. So that was taken, and then we tried all the permutations of things. In the end, we settled for this one, but there's only 2 hard things in computer science, right? So that's what we named it. Stands for Hugging Face Golang Transformers. And the idea is essentially simple. Is first of all, we want to stay as close as possible to Hugging Face pipelines. So it's supposed to be a one-to-one translation of that, right? So that you can sort of really stay close to the state of the art of these kind of things. the second principle is we focus particularly on on supporting Onyx model. And if you don't know what that is, it's essentially a format in which that these transformers models can be saved to. It's the Open World Network Exchange. It's backed by Microsoft. It's written in C. And any model that is supported by a Hugging Face can be, with 3 lines of Python, exported to Onyx and therefore loaded into the library. And very important for us, it's supposed to run this kind of models tightly coupled in your Golang application, right? Without, for example, necessarily need to access the internet. So these are kind of like the three principles of the library. And I want to maybe switch to code here, just to, you can see it, yeah. So then, that's essentially what we ended up with. So the idea is essentially there's 2 things that you have to do, right, when you want to implement this kind of thing. You need to think about the tokenization part. How do I take a string and then split it into tokens, right? Then once you have done that, how do I interface with an Onyx runtime model, right, and run these tokens through the model? And then the third thing is, how do I take the output of that, which is the vectors, and do whatever specific post-processing needs to be done for the pipeline that I'm interested in. The simplest thing you can do is you can just take the vectors and calculate the similarity, like what I just showed at the beginning. But if you want to do named entity recognition, you need to take that, and then you need to calculate some probabilities, and then see, okay, actually this word is most likely of class person, and this word is more likely of class location, and so on and so forth. And so this is what essentially our library does, and it allows you to sort of load essentially any Onyx export of a Hugging Face model into Go, and then just run inference with it. So for example, in this case, you see, well, I import the library, then I create a new session object. This is the object that will actually hold all the initialized pipelines, right, all the models. And it's important with this object because these are C objects in the background, right? So they are held in the struct, and then if you destroy the struct at the end, you free the memory. So that's basically what's happening in this defer over there. And then we integrate with another library, actually, that is the Hugging Face model downloader here, that allows you to directly download models from the Hugging Face repository. In this case, I'm downloading this model, which is a sentiment analysis model, which, well, takes a sentence and says, well, it's negative or positive. Right? So using the session object, I can actually download the model locally, and then I can initialize my pipeline, right? And how does that look like? Well, I create a config object, a config struct, and I say, well, it's going to be a pipeline of type text classification, right? Currently, we support only 3 types of pipeline. We support feature extraction, which is get the vectors out, text classification, which is use the vector to classify a sentence, sentiment analysis, positive, negative, and so forth. And the last one is token classification, which is look at the words in the sentence and classify what class they are, yeah? So here I'm initializing the config for the text classification, and then I can initialize a new pipeline, and I need to pass in the session object and the config object, and then I get back a sentiment pipeline object, okay? That sentiment pipeline, that pipeline that I just initialized is also held, well, it's a pointer, so it's also held in the session object, basically, so that when you destroy the section, you destroy all the pipeline you've created, right? And then once you have that, I can pass it a batch of strings, as you can see here. Like here I have 2 sentences, this movie is disgustingly good, and the director tried too much. And I can perform inference with the run pipeline method, and then I get the struct, which if I marshal looks like this, and as you can see, I get for the first one a positive label with almost certain, which is quite clever, right? Because the first sentence is, this movie is disgustingly good. So disgustingly could, you know, if the model was dumb, could lead him astray, but it actually does not. Right? It recognizes that it's actually a positive sentiment. And for the second one, we get a negative sentiment, which is exactly the sentiment of that sentence, right? So that's basically what that does. As I said, we support these three types of pipelines where we're looking at adding more, in particular for computer vision. One thing I want to touch then on is how did we implement this thing. So for me, this was quite interesting because I come from Python world, right? So Go is, I've worked with the Go in the last, let's say, 2 years. And so it's been a very interesting experience to struggle with the Python, with the Golang type system, to try to understand how I could actually reuse code rather than copy stuff over. And I think I kind of got a bit the gist of it by now, maybe. The main implementation is essentially we have a so if you look at the Python code of transformers, right, of the Eigenface guys, they have a base pipeline class, and then all of the different pipelines basically they're implemented with inheritance, right? So what I do here is kind of like something similar. I have a base pipeline concept because every pipeline has some of the same things, right? So every pipeline will have a path to the Onyx model which needs to be loaded in. It will have a file name. It will have some options for inference that you can pass, which can regulate how fast inference goes, or whatever, and so on and so forth. And then specific pipelines just like, for example, the token classification pipeline, just embed that struct, right? And then they can have properties of their own, so that works nicely. And then there is a pipeline interface over here, and as you can see, the main, well, it has a few methods. Well, there's this destroy method, very important because we need to free the C memory if we don't want the pipeline anymore. But then it has the run method over here, and that run method is essentially the method that is called to actually run this pipeline. If you look at that run method, for example, for the token classification, you will see there's essentially three. I mean, actually, the run method is the one that defines the interface here, but every pipeline has kind of the same steps, has pre-processing, which is take the string and make it put it into tokens, then do the forward pass within a network, and then take the results and clean them out so that you get the output, right? So you could also use those to define the interface. And that's essentially what you see here, for example, in the case of the token classification pipeline. And if you look at, let me put this down. If you look at what happens, for example, in pre-processing, over here, this is the part that takes the string and turns it into the tokens, right? So the initial vectors that you've seen. And this is essentially calling the Rust Eigenface implementation of tokenizer, right? So we bind to the Rust tokenizers through C, so that we are in sync with the state of the art of that, right? So we can keep in sync with that. Me and Rob actually did some contributions to the tokenizers bindings, Go tokenizers bindings to the Rust library. And the other one is the forward pass, which takes the output of that and passes it through the network to get a prediction. And that's the one that actually calls Onyx runtime, which is essentially this binary object. It's all C in the background, so it binds to C, and it essentially passes the batch, right, of tokens and gets the vectors out and brings them to Go world through CGO, and then post-processing all happens in Go, essentially. Right? So that's kind of how it's structured. Oh, that's kind of like how it's structured. So that means that with Onyx runtime and with Rust, we are always in sync with the state of the art, right? And that's kind of important for us. And then the last thing that I will mention is how do you create, there is this thing that is like annoying me to no end, but unfortunately it is what it is. It's like, I want to be able to create a new pipeline, right? So ideally, I would be able to do that. I have the session object, right, which holds all of the pipelines that I created. And what we originally had was you could take the session object, and we had methods, struct methods on that object that said, create a new, token classification pipeline, or create a new sentiment text classification pipeline, right? So each method to create different types of pipelines, right? I didn't really like that, so we then moved to use generics to do this, right? So then what we can do is we have this function here that is a new pipeline, which can create new pipelines, and you can pass it the session object, and you can pass it the configuration for that pipeline, right? Which is a pipeline config object, but instantiated with a specific type, right? Pipeline type. And then actually the compiler is smart enough, it can do all of the type inference thingy. And then inside here we say, okay, what is this type that you cannot switch on the generic directly, you cannot switch on T, but you can do this thing, right? And you say, okay, well, any pipeline, and then you convert it to the type, and then you can do the switch, and then you say, oh, well, great, if it's a token classification, do this, and so on and so forth, right? So this kind of works sort of nicely. To be able to have one method that is actually type safe to instantiate the pipelines. The funny thing is that you can't have it as a method of session. So it needs to be a function, right, with this generic argument that you pass the session object to. It cannot be essentially a struct method, right? Because Go does not support generics in struct methods, right? And so then I went into this rabbit hole of trying to understand why is it that it doesn't support this, and there's like a whole Q&A about this because people have been bitching about this. So why is it that it doesn't support it? And there is actually, I have a link on the slides. It's quite interesting. It's essentially because we have interfaces, right? But they're not explicit. They're implicit. And struct methods are supposed to implement interfaces. And because they're implicit, you can actually cook up with generics examples where essentially you don't know essentially if the interface is implemented or not, and they discuss some solution. Either you have to make the compiling more complicated, or you would just have to say, well, struct methods don't, with generics don't implement interfaces, right? So that's why you cannot have this, for example, as a method of session struct, but it needs to be a function like that. And actually in that discussion in the Go Q&A, Go FAQ, they say, well, sure, we don't really care about this because you can actually have just as a normal function like I'm doing here, right? And it kind of works, right? But in this case, it would be nicer if it was a struct method just because the session object is needed to track all of these pipelines once they are created. Because then I want to destroy all of them in one go to avoid memory leaks. And so it would be a bit nicer if I could put it as a struct method over here. So if someone has better ideas on how to do it, I'm open to hearing them. And so that's that. And so what we have now, as I said, we have feature extraction, right? Token classification and text classification. This is what we currently have. This is thread safe, right? So you can actually call these models from different coroutines for inference and it will work. We are now trying to implement object detection and feature extraction from images. And the nice thing about relying on Onyx runtime rather than trying to build things from scratch in Go is that if I want to do GPU inference, I can just use Onyx runtime to do it with CUDA, and I'm almost there, right? So that's like sort of the nice thing about it. This I already discussed, and I think that's what I wanted to discuss today. Unfortunately, I didn't. So we use this in production actually because we use it to run like hundreds of thousands of strings for that similarity application. And the next thing I want to do is some benchmarking, right? Compare it with the baseline Python implementation. Didn't manage to get it for this talk, but maybe next time. And And the most important thing you can do, of course, today is to go to the library and give it GitHub star. If you do that, you have achieved your goal for the day. And that's that. Yeah.
Yeah, so does the Python version also use the Rust tokenizer and the Onyx library?
Yes. So the Python version has two tokenizers. It has the very aptly named slow tokenizer, which is the Python version. It would have been fine if it would have been the Rust version, right? No. So the slow tokenizer is the Python version, and the Rust tokenizer is the fast tokenizer, and that's also what actually Python binds to, right? Also through C.
Yeah.
But Python C interface is actually pretty good. So, yeah. Yeah.
You mentioned that it's used in production. Other than your team, who uses it in production, if anybody?
Say it again. Sorry, I didn't.
You said it's used in production already, right?
Yeah.
Other than your own team,
Yeah.
is anybody else using it in production?
I think for now it's us,
Okay.
because we just this is new,
Yeah.
right?
Production in clients, so.
Oh yes, yes. So it's we use it in our software when we deliver it to our clients. So yeah, that's that.
So how's this Onyx runtime? That's a C interface, I suppose. Is
Yeah.
it stable? Does it change?
No, so that's actually the nice thing about it. So it's backed by Microsoft, right? And it has, so it's written in C indeed. But the advantage is that it's very stable. It's an industry standard actually for exchange in the format of neural networks. It offers a lot of optimizations, right? So you can with Onyx you can, for example, make it run faster for inference because you can optimize the structure of the network, and you can also do this quantization things, but which is it could be a whole tool, but basically it just helps to have faster inference. So it's quite like a standard, and Hugging Face is also supporting that standard because they provide, if you look at the Optimum library, in 3 lines of code you can take a PyTorch pipeline that they have and export it to Onyx. Now in the export you lose all of the pre-processing and post-processing, right? And that's kind of what we reconstruct on our side because it only exports the PyTorch model itself. Yeah.
And then the Onyx runtime, that's part of it is in Rust or is all of it?
Onyx runtime is C.
Okay.
C++.
So are you afraid of introducing C code in your nice Go runtime? Suddenly your pointers go all strange? Or is it only a small piece of C and lots of, let's say, data?
I mean, I would say the interface is quite small in a way because what we're doing is essentially just passing like pointers to the strings that need to be processed, and everything happens in C, and then we just get.
Yeah, but do you think all the C part is all correct and?
Oh, do I think that all? Well,
that's why I don't like C in my Go applications.
There's a lot of people smarter than me that work on Onyx runtimes. I think so. So I think at least tokenizer is safe, right? Because it's Rust. So then we can be happy about. But no, yeah, I think I have quite some trust. I mean, Onyx runtime has been there for a while. It's used in a lot of applications.
It's still better than Python in given time. It's still better than Python.
Yeah.
And was it correct you're loading the shared object or shared library to load a model? Each model is a separate library?
No, so basically there's the tokenizer library is statically linked at compile time.
Yeah.
So that's kind of compiled from Rust, from the Rust repo, and then statically linked. And the Onyx runtime is an SO object, so that's dynamically linked. My runtime, that actually is also what allows you to run this on Windows potentially. And you only need those 2 things, right? So we actually have a CLI, like I wrote like a little CLI which allows you to, if you are on Linux VM, you can actually download the AMD64 versions of those, well actually CLI and of the SO object, and then just run transformer models without Go or Python.
Yeah.
Right? Which is kind of fun.
Yeah.
Yeah. So from the CLI, from the terminal. So yeah. Yeah.
One of the 3 points on your roadmap,
Yeah.
I think was features from image or something.
Yeah.
What's the point? Describe that. What is that? That's like describing an image or something.
Yeah, that's basically getting like in the same way in which you get like an embedding from a string, right, which is just like a vector. You can also get a vector that represents an image to do image similarity, for example, right? And of course, the way you do that is different than from strings because, well, images are different objects; they're two-dimensional, so you have different models to do that. That still spits out a vector, like an array of numbers that encode the image, but it's a different model, and so that's on the roadmap to support. The idea being that you can, like what kind of we want to achieve is you can do your training in Python, with eigenphase, you could do fine-tuning of the transformer, works nicely, but then once you want to run it in your Go application, I think this is the best option. Well, I mean, we wrote it, so of course I would say it's the best option, but I think it's the best option you have out there, because otherwise you are in one of those 3 boxes before. And I think all of them have issues. Yeah. Yeah.
Did you do, or did like any performance benchmark in between the previous implementation and UBUT?
You mean the
gRPC?
Oh, the gRPC one? No, we don't have, that's the thing, I don't have benchmarks at the moment. That's the next thing I want to do. I do know that, but this is anecdotal, I do know that with Cybertron, which is the other library, people have tried to use, for example, embedding models to do embedding of, let's say, 20,000 titles. But it was slower than having just a gRPC service with Python, so then they basically fell back to let's just have a gRPC service with Python. It's definitely important to do the benchmark against that, but for me it's also the ease of deployment, right? Because with that thing also comes with the whole, particularly in enterprise deployments, I need containers and so on and so forth. With this, it's just basically a Go library that I load, right? So it helps me quite a bit.
Okay, thank you, Ricardo. I think with this we are done for the day. But before we go, we do have some presents for the speakers.
I can stop sharing.
Yeah, we can stop sharing. So, before you go, Ricardo,
Yeah.
we have one cup from the Go organizers for you,
Oh, thank you.
and as well one water bottle from our wonderful host,
Thank you.
the Things Industries.
Thank you. Thank you very much.
Also, okay, Eric, you're next to me. For our lightning talks, we have a nice chocolate, milk chocolate, with our Go logo. And Arno, thanks for the talk as well. Okay, guys, before you go, we also have water bottles for you guys. I completely forgot about those. Sorry. Okay, and Johan. Yes. Here is a nice Go mug, so you can keep it at your table and remember us.
And my own water bottle.
And your own water bottle. Thank you everyone for coming, but I want to say thank you to our wonderful hosts. Thank you for having us. Hope you guys will have us again. Yeah, and also before we go, the Things Industry, they have a conference up soon. So, Johan, can you please explain about it?
Yeah, so we have every year we have the Things Conference, which is a big event in the Kromhout Hall here in Amsterdam, 2 days in September, and it's all about LoRaWAN. So if you want to know more about LoRaWAN or about IoT, low power wide area networking in general, then you guys are all invited to come to that event. We will distribute 50% discount codes on the meetup through the whatever channel is best to do that. So that would be nice to see you there.
When is it?
It's I think 25th and 26th of September. Yeah. Yeah.
Okay, thank you, Han. So do look out for the email. We'll be sending the tickets with a 50% discount soon.
Yeah.
And with this, I do want to ask: did anyone decide to do what's new in Go, or not yet?
For the next one.
For the next one. So, do we have volunteers?
Who's done it before? Raise your hand. You've already done it before.
Yeah. We have a rule. You're not allowed to do it if you've done it before. The whole point is to get new joiners to speak up and talk. So, yeah? No one?
If you're not a volunteer, you'll be volunteered.
Yeah, exactly.
Voluntold.
Huh?
Voluntold.
Yeah, you're gonna be voluntold.
Let's go get some drinks.
Okay, so in this case, let's go. There's a bar here. There are a couple of bars nearby. So
Do we have to leave at a certain time?
yeah, we do need to leave. I think at 9 latest. We have to be out of the building. So the conversation can continue in the nearby bar. There are a couple, I think. Don't remember the names.
We get a group. Just stay here for a while, then we go all.
Yeah.
to the bar.
Okay, then thank you everyone.